basically exactly the same thing. Oh, there's one other thing I could have worked on. Let me throw this out really fast. This is simpler than namespaces, and I could do it tonight, so maybe I'm hyped to do it. All right. Hold on. Stop the wagon. So the other thing I could do tonight is, remember how during the talk I talked about, hey, I'm setting all these values to 0 and stuff. And that's kind of dumb. You know, sometimes I don't. So like the particle emitter has lots of stuff that's not 0. But you would like to be able to not have to set things to 0 and they get default values. And you should be able to type some kind of uninitialized thing to make things not initialized. And then on top of that, arrays ought to get initialized to default values, which currently doesn't happen. So I could do that. And that's a smaller thing that actually, there's a chance that I can actually do all that tonight and get it working, which might be more fun to watch. So what do you guys think? I could do that or namespace. Default values and explicit uninitialized versus namespaces. Structs can include types too. This is going to be a language where types are first class. People are into default values. No, arrays wouldn't get assigned to null, but if you have, well, if they're arrays of pointers, they'd get null. If you have arrays of floats, they'd get 0. Okay. Default values. Let's do it. So that'll be nice because too, then it means that I can relax more with future code that I write, and I don't have to worry about uninitialized values, which will mean I can program further things faster. Okay, let me outline what has to happen here. Well, the first thing I'm going to do is just make everything initialized to 0 if you don't give it a value. There's basically two components to that. One is if it's a primitive type, like a pointer or an int or something, then when I parse it, if it doesn't declare a value, I'm just going to put it in there at parse time. That might be a little cheesy, but I think it's the best way to do it. It's the cleanest with least code. Then, once I've done that, then both the bytecode and the C compiler should work correctly. So at that point, I can just test that and verify that it works, and that should be cool. Then I can make sure that arrays get initialized. And I could try doing an array on a struct and make sure it's initialized, which is a little scary. Code should handle that. And then if all that works, we can do explicit uninitialized. So in the same way that I did things in a phased way yesterday, I can do them in a phased way today. How do I feel about optionals? Some flavor of optionals is cool. I don't like, people go, right now optionals are trendy and people think they're cooler than they actually are, in the same way that people think every programming language feature is cooler than it actually is. Okay, I'll read Strostrup's multi-methods thing that someone linked, even though I disagree with Strostrup about basically everything in the world. No, it doesn't mean that code that shouldn't. So someone's saying default initialization means that code that shouldn't compile will compile all anyways. That's not true. What it means is that you don't have to set values on things most of the time. Like almost every time I initialize something, I initialize it to 0. It's stupid to have to do that. Like, it's just tedious. Anyway, I'm going to email that multi-methods just so I don't forget it. But like, adding anything new to C++ is a terrible idea to begin with, and then if Bjarne says it, I'm guaranteed to disagree. All right, I've sent that to myself in email. Make floats initialized to nan. I probably won't do that, but let's make a test case. Let's delete all this enum stuff we were doing yesterday. Let's make a test case that like doesn't initialize things, and it's going to be interesting because how do you do that? Like, if we put something in BSS up here, like if we just say, you know, like that, or sorry, like that. In the C standard, that's initialized to 0. So because we're generating C code for our output, that's not a good test. We should test that for bytecode, actually. But for C code, that's not a good test because we're piggybacking on the compiler there. But if you do something on the stack, then that, right? So I could just do this, like A int B float, and I can printf A is %d, comma A, B is %f, comma B. That right, so the C compiler is warning at me. That's the C compiler's errors because it comes after I ran the C compiler. So it knows I'm doing something bad. We don't actually detect uninitialized values right now, and that may not be something I do for a long time because if uninitialized values are very, very rare, then detecting them isn't very useful. Anyway, okay, so I'm going to run it. Well, that wasn't very useful. I think, okay. So I have an option to compile and debug, right, which I've just compiled with different options. And that might, okay, so there we go. That at least gave us something. Debug, tends to initialize the stack and the heap differently. So at least if we change it, and we can also do something funny like initialize all. You know what? Let's do something funny so that we really know it works. We'll initialize all ints to some non-zero value, and we'll initialize all floats to some non-zero value and stuff. Do I still plan to YouTube last night's stream? I guess so, if people want to watch it. Yeah, I mean, that's what I'm talking about, initializing everything to 5 or something. So let's do that. Let's do that. Where do we start? Let's start with declarations in Parser. And I'm trying to search for an error message with neither, no. I'm trying to remember the wording of an error. Okay, it's in Code Manager. Can't have a declaration with neither type nor value. I guess I don't do that in Parser. I do that in type inference, which is possibly a better place to do it. So let's do that. That's why I was looking in the wrong file for it. So the reason I remembered this error message and can search for it is that, you could do a declaration like this. You could say, you could say x int, right? You could say x int equals 3, or you could say x equals 3, right? So we handle all those cases. Like, do you have a type? Do you have an R value? Do you have an R value and a type? But you can't, do this, right? That's nonsensical, and so that's what that error is checking for. So that enables me to remember, like, oh yeah, this is the code that sort of looks at which of those exist. Okay, so we're going to say if the declaration has no expression, then if it has a type, whoops, we do some things. Can't type, else we do this error. Okay, so now I have to look up so my type is a type definition, and the type definitions that we want to generate default values for are all the default types in the language. Once we've done that, then any compound type that you make should, at its leaf, initialize its type, which is interesting. Let me write down. Yesterday I would mention things and then forget to do them. Let me write down. There's a system where the compiler knows when code needs an initializer, right? Like there's a flag that I say that says, hey, this thing has an initializer because it's got a compound type or something, or you set something, and I need to make sure that triggers in this case. I think it will automatically, but I need to make sure. Okay. So let's see what we do up here. If we have an expression, we check that types match, blah, blah, blah. Declaration is function body. Okay, I don't think any of that matters. Okay, so if we have a type, how do I... Oh, I can just say, I should have inferred that already. Let's do it again just in case. So I'm going to go infer types, decl my type. Let me make sure that's even the right function because there's this pointer cast that confuses me. I was a good citizen and I got rid of some of my warnings. Today too, I've still got a lot of warnings. Some of them are hard to get rid of, like this isn't a giant macro expansion. Yeah, F open, bite me. Okay. So this infer types just makes sure that I detect what type it really is. If it's, later on it could be a parameterized type, but it could be a more complex expression. So I make sure it's inferred, and then I say, okay, if my type, and then I'll make an alias for that. Auto inf is decl my type inferred type. So if, now I have a bunch of definitions for the basic types that are laying around, so I can just pointer compare. So I can say like if inf is equal to interp type def, let's say void, well, we do nothing since a void variable can have no value. Else, so I'm just going to do this for a bunch of types. I mean, we'll restrict it to just a few at first. Actually, let's. So here's sort of what all our type defs are that we have. String is an interesting. String handling is another thing I could do on a stream sometime because I totally haven't thought about it and it's not really existing right now. So let's start with int. That's easy, and let's just make sure that works. If it's equal to int, then decl expression equals make integer literal interp 0. Oh, 5. Well, let's make it a really unmistakable number. Minus 237. There's no way we're going to get that by accident. Right, infer types decl. There's going to be a more compact way to do this, actually, rather than naming all those frickin' types. We'll get there. First, I want to make sure this works. So we infer types on decl expression. And then are we doing anything up here? We check that types. Yeah, you know what? I should do this. I should do this way up here. So, because whatever code runs in here, when I do have an expression, I always want to run after I set this. So if it doesn't have an expression, and it does have a type, then we can do some things. We set the expression. I don't need this infer types because I do it down here. I guess I did need that. Let's see what happens. Compile. Whoa. I really broke something. Why is it spazzing out? I must have broken. Oh, right. There was an if here. If bang decl my type. Perils of editing when tired. All right. So A is initialized. Check it out. That was the int. Minus 237. Hey, we did something and it wasn't a big hassle and it actually worked. All right, so now there's all these integer types. Right, so like up here is all my integers, here is all my floats, and let's handle all of those because we want them all to be 0. And the way we can do that is by saying, you know, I have these number flags. If you saw the enum thing last night, you might have seen that there's these number flags that get set in various conditions. So I can say, let's take care of the numbers first because that's a lot of stuff. If inf number flags, that means it's a thing. Otherwise, if it's void, we'll do that. Right? And then some of our things are unsigned, so let's not be minus 237. Let's do plus 237, which, by the way, is the room number of one of the computer labs where I used to hang out in college, 237 Evans Hall. I wonder what is in there now. I used to play NetTrek in there all the time. Okay. If it's number flags, then it's either a float or an int. And if inf number flags and number flag float, else. Now I don't think I have a make float literal, but I will. Make float lit. No. Make integer literal. Make float literal. Literal number. Float value. So all our literals are big. They get made big, and then you know, type checking coerces them to whatever the type of the variable. So we don't have to make overloads of these for like every single size of thing. It's a number. It's got this value, and it's float. That should be it. And let's not make it even, so floats, let's make a different number. 69,105.1. All right, so we build the compiler. That didn't, oh, I got to recompile the program. Numeric constant too big for type. Okay, so the reason we're not getting very helpful error messages here, so let's fix that before we do anything further. See, I've got this null 0, 0. So the problem is the way we're generating those error messages is that we're looking at these at the expression, right? And the expression is just this literal that I'm making out of nothing. Like when I call make integer literal, I like make a 237, you know, out of nowhere. And those don't have file and line information on them. So I should set that, and I don't remember how to do that. So set, how do I do that? Set file and copy line Copy file. I'm just guessing like what. I could just check line number equals. Who in the code does that? Who in the code does that? Copy literal. Set ast line info. There we go. AST stands for Abstract Syntax Tree. It's an acronym, but I don't usually spell out acronyms in my code because I like to always know how to type things, and I don't want to have to guess if something's an acronym or not. So I always, first letter is capitalized, rested letters aren't, underscore, and if that looks dumb because it's an acronym or whatever, I don't care. So I can do this. I can wait, I don't want that. I don't want that one because that's for use in the parser about where we are in the file. I want one that copies from something else. Here we go. Oh, that's part of a different thing. Okay, it looks like maybe I don't have this and I'm just doing it by hand. All right, so I'm going to make it. I'm just going to make it. I'm going to say, I hope this isn't duplicate code, but whatever. I'm going to say copy file and line info, or copy location info, that's shorter. And there might be more to it than file. There already is file, line, and character. So copy location info. And I always do my copies source to dest. So I'm going to copy from decal identifier into decal expression. So when we get an error message, it'll be where the identifier was, assuming there is an identifier, but what else? Actually, we know that my type is here. Well, we know that we have an identifier. I don't know. Let's do my type anyway because it's closer. If this ends up doing something screwy, we'll change it. Okay. So, void copy location info ast source ast dest dest line number equals source line number. Boom, boom, boom. Why did I do that? It's better to do this. File name, character number. All right, compile the program. What? That's weird. Why didn't that work? I did all that. Copy location info. So weird. All right, well, let's break in numeric constant too big, which I don't know why it's saying that. I guess I've got 3 places where that could happen. It's probably a weird corner case, but it could be a very common case. I'm actually happier when a problem is due to a common case because that's usually easy to debug. Corner cases are weird. All right. So I've got some site. It's a declaration. Oh. It is a corner case. So this is some kind of manufactured declaration that didn't come from a file or something. This could be hard to track down. Maybe it's from our enum stuff from yesterday, all that funny business. What is this? Oh, God. This is basically hilarious. So, when I, at startup, right, I create declarations for all the primitive types just so that you can resolve against them and stuff. And I'm going in and I'm trying to stuff in default values for the declarations of primitive types. which is not what we want. This is totally not what we want. So if it's got a type, and well, if let's say if there's no expression, and here's how I know if it's a primitive. If it's not well, you know, I could use an alias here. No. And decal identifier and bang decal identifier name is type leaf. I'm doing this Lisp style atom system where the names are all shared and like, okay, well that compiled. Hey, look, it did what we want, except didn't I want the float to be 69105? No, okay, I put these in the wrong place. Stupid bug. 69105.1 237. All right. That is good. That is good. Now, well, let's test a struct that's uninitialized, and let's make sure that that works. I believe it will. So let's say hello is a struct. Is that how I even declare structs? I get confused by my own syntax sometimes. I don't need that. Resrov is an int. Prots is a float 32. Prots 64 is a float 64. Cowabunga is a float. MyChar is a U8. Dude is an S8. The binding of Isaac is an S64. Okay, so now, if I had an introspection system, which would have been one of the other things I could have done tonight, or started tonight, then I'd just be able to iterate over everything in this struct and print these out. I can't do that yet, so now I'm going to do horrible things. I'm going to say printf something is God. Okay. Boom. Resrov. And I have to get my printfs right because we don't have smart printf yet. This is a stupid test. You know, I should do this whole test, but like this is starting to be a tedious and annoying test. I wonder if I could have thought of a better way to do it. And I don't remember all the right printf thing. Printf is such a pain in the ass in 64-bit because like long floats, I think, or no, wait, %f is a long float because everything gets promoted to double, but integers are like LLD, and LD is the same as D because you're on a 32-bit, I don't know. It's a giant mess of garbage. Cowabunga. MyChar is do I want to do that? No. D. Dude is dude. Okay. So maybe that's some kind of a test. Let's get rid of these. I don't know what that's going to do. Numeric constant too big for type. Okay, that's a bug. So a U8, it's complaining on line 8 and line 9. So a U8 ought to be able to incomplete. Why does it think 237 will not fit into a U8? 237 won't fit into an S8, but a U8 it will. And I tested that at one point and it did work, so that is broken. It's a regression or whatever. So let's make that number lower than 237. Let's make it 113. It still thinks that. That's weird. Okay, so I'm going to comment those out for now, and then we'll debug those. Let's see what happens with everything else. 8-bit numbers seem to have a problem. Was that output still backwards? Did I play Sean Barrett's The Weapon? I've played most of Sean's games, but I don't remember that one for some reason. Was what output still backwards? Oh, God. Okay, right, so I want to say A is a hello, and hopefully this all works. Who knows? Undeclared identifier and struct reference, my care. Okay, right, because we didn't do that and we didn't do dude. Interesting. Am I not? Yeah, I don't. Maybe I'm not initializing A properly. I'm not. Let's try this. A equals new hello. Oh, sorry, I'm writing C. A colon equals new hello. Okay, well that's a bunch of garbage. So it's good to test things. What do we want to do to debug this? Let's look at the C code. So now this is buggy, at least in the C code. It may also be buggy in the bytecode or not. Let's see. We're not calling the implicit initializer because I didn't set that flag, because I bet you I set it during parsing. Remember when I wrote that down and said I need to make sure that that happens? I then proceeded not to make sure that it happens. That's me in streaming for you. So basically what should happen is if the initializer, which is like a constructor, but I'm not calling it a constructor because I don't want to get into a C++ mindset. And if I call it a constructor, I might start adopting features of C++ constructors, and I don't want to. So after we call malloc here on this, we should call its initializer as the next line. And I know that works because it works for other stuff. So this isn't working because we snuck in the values after it tested that flag. And I bet you it'll start. Here's my test of that. If I add any other value that's initialized, so sleepy is 5. Now it'll work because this has an initializer because it needs one for that 5. Yes, see? So there we go. Mental debug skills are good. So let's go back and fix that. So I'm going to get rid of sleepy. Let me put this in C++ mode. So much brighter. Okay, I'm going to, I bet that's set in the parser, right? Initialize, no. There's no has implicit. Okay, oh, I called it a constructor here. I fibbed. I guess I did. I probably did this early enough that I hadn't yet adopted my policy of not wanting to use the word constructor. and initializer is more typing. So I just had the urge to like go in Visual Studio and search and replace that, but I'm not going to do it yet. Okay, so really, you know, like I said, I could have done this in the parsing phase, and then this flag would have automatically been set, but I'm going to keep it where it is because I'm honestly not sure which place is better. I feel like type inference is possibly a better place to do it. So now we know going into this that we didn't have an expression. So if we do have one now, we set it successfully by matching it against the type. We didn't have an expression before, but now we do, so we must have just added it. So desk is a, oh god. Okay, no, there's a different flag. I don't need that flag. I need a different flag. No, oh no! This may not be the right place to do this, because okay, so here's the thing. Here's the thing. I have to be really dedicated if I want to move it, because has implicit constructor. So that gets set when we're parsing a struct if the member has an expression. And I guess I should say, and it's not const, but whatever. Basically, everything's going to have a constructor, so that may not be a worthwhile optimization to do. Okay, but also, if a struct includes another struct, oh, we propagate that up. Actually, that propagation doesn't happen here. Where does it happen? Okay, so here in type inference, or is this in type inference? Such a big function, I gotta scroll to there's probably some Visual Studio way to go to the top. Yeah, so we're inferring, and if it's a struct, we infer all the members, and then okay, we need to propagate implicit constructors up, right? If a struct has an implicit constructor, then any struct that holds that also has to have an implicit constructor, even if he doesn't have any members with default values, right? So you need to propagate it up, but that happens after this. So can I reach out of a declaration into a struct? I can reach out into my scope, so I can do that. But I can't really. I could hack it by going into this owning statement and stuff. But I feel like what is happening is that in fact God is telling me, or the program is telling me, that this is not the right place to put this. So I'm gonna leave it here, sort of. I'm gonna comment it out, and I'm gonna put this stuff that I've been doing into the parser, because it happens earlier, and then this flagging that I'm talking about will happen automatically. Yes. So in the parser, parse my type equals. Okay, so we're parsing a declaration here. We've got the identifier already. We looked at this a little bit during the enum thing yesterday. So we're back to our old friend here, and we're about to make it more complicated, unfortunately. Okay, so if there's a value, we do this stuff, right? Now, if there's not an expression, we're going to hit it before it ever even gets assigned. Generate default values for basic types. I don't have an official term for that. Oh, and of course, we're calling it result here, but you know what? Autodecl equals result, because I don't want to have to keep changing the variable name back and forth every time I paste it like I did last night. Okay. So if we've got an identifier and it's not a leaf, then we don't do this. Oh God. So this may not work either. So the problem here, this will work for all the basic stuff I'm doing right now. Because we're saying, int whatever, and at this stage in the pipeline, I can detect, that that's a primitive type. But, we don't have type aliasing yet. But if you have type aliasing and you say that a type is basically an int, you need to be able to evaluate that, and that's why I was putting this in type inference. So it's funny, it's a relatively simple thing, but there's always a catch about where you want to put it. So if I put this here, it'll work for now, but it's maybe not a very future-proofed way to do it. Okay, so I can make this work now, and I have to rewrite it later when I do type aliases, so that seems like an unfortunate decision. Or I can put it back in the other file, and what was the problem? The problem was that I have to reach out and tweak my struct and say that it has a static initializer. Or, actually, I can change the way that that flag gets set. That's the right thing to do. Let me undo all this. Undo. So let me just get this code turned on, because there's a little bit of uncertainty now that I've been moving stuff and pasting stuff. Okay, let me just make sure this still works. What did I miss? Oh, look, it's called... Right. So this doesn't happen yet. What I can do is actually just move... Right. That's actually what we expected, because remember I took that 5 out. Okay. So why don't I just set the struct has implicit constructor here? Because I don't think we need to know that as early as we did, right? We just need to know it at the end of this, because anyone who contains us needs to propagate it up. That's the only time, right? This is the only time this flag is being checked in this file, and there. So I'm going to go into the parser. I'm going to get rid of that. Let me check the implicit destructor too, because while I'm being parallel, yeah, nobody needs to know this that early. So I was doing that stuff. Oh, but I need this struct description. Oh wait, I have it. What? Why am I freaking out about this? I must have it because I'm it's right there. Duh. It's right there. Anything. Now I've totally lost my position. Okay, so we're down. No, that's not where we are. Yeah. Okay. So I don't. Oh, never mind. Okay. I was confused. I don't have that pointer handy. Okay. I don't want to reach out from this declaration and poke the struct. What I want to do is here, like I said, when I'm inferring types for a struct description, I iterate over all the members and do some stuff, right? After I infer the type for the member, where is that? Oh, that happens here. I infer types for everything in that scope because struct scopes are unordered, so you want to be able to keep iterating over them until you converge. Okay, so after we've inferred all the types, then we can do this, and here we can check to see if we have any default values and or done this. So my theory is that nothing will explode if I move this to here. Why am I setting this implicit destructor bool? I think that's old. Yeah, that's not even. That's dead code. Okay, so if we have a declaration with an expression, whether we just manufactured it or not, or whether it was specified by the user typing it in, we need to say we have an implicit constructor, and just for the purposes of symmetry, if that declaration declares an owned pointer, which is that exclamation point syntax that I talked about in the first talk, then we do this. That seems pretty good to me, unless I somehow. We shouldn't, for any reason, call this code twice, but if I do, then I might blow up because I free something twice, but I don't think that'll happen. Yep. Let's see what happens. Decl undeclared identifier. What? Oh, it's it. All right, let's call it it. All right. Now what? Declares owned pointer. Is in parser, declares owned. That's a static bool, and nobody else uses it. Oh, yes, they do. Declares owned pointer. All right. Yay! That's pretty good. So why don't I take a 5-minute break and have some chocolate reward treats, sorry. I have these fine. I went to the chocolate store today. These are Rashuti burnt caramel almonds, and they're delicious. Chocolate covered, powdered. So I'm going to take a short break. I'm going to make a tea. Then I'll come back and we can cover any questions. It'll only be about 4 or 5-minute break. I'll come back. We can talk about any questions about what I just did. And then we can talk about the next thing, which is making sure that arrays of floats get initialized. And think about if there's anything else that should get initialized that I forgot. And once like arrays of floats and all that work, then oh, I should test, before I do that, I should test this local version, right? You shouldn't have to new something. Whoops, I don't have to do that. All right, that doesn't work still. So there's two things that have to happen. We have to initialize arrays of floats and local structs. That surprises me that that doesn't work, because I thought I wrote code that required that, but maybe it doesn't. All right, 5-minute break. I'll be back. Thanks for the reminder. That's another thing to do. Those still won't work. That U8 and S8 thing, I don't think that'll work. I'm going to make that a lower priority bug, because I want to get the base functionality working for everyone else, and then we'll fix U8 and S8 as well. Okay. While I was making tea, I thought of one more thing to test, which is whether this, so we know this is broken in C code right now. This A hello is not getting initialized, even though it should, in C. The new hello was working, but the stack-based working. It may not be broken in the bytecode, because in bytecode that happens differently. So what I'm going to do is I'm going to do a run. I've never run main. I wonder if that even works, because I do a weird thing. Okay, now check it out. So the bytecode version of all this works correctly, which is promising. So we only have to debug one thing. Right now, if I run, that was the compile time version, right? So we got all those values. The runtime version is going to be broken. So we only have to fix the C thing, which is nice. It's less work than we might have to do. But let's do some questions first. Dude, I hate Teo dark chocolate. I hate Teo bars. They're nasty. Don't eat those. Wait, I saw a question for me up the thing. Do I want my language to be usable by folks who don't have a good practical knowledge of C++? Yes, C++ is crazy complicated. I don't think I'd encourage anyone to learn it now. So yeah, I'd love people to use this language who have never used C++ at all. That would be great. Tomato soup is good. There is no garbage collection in this language. If you wanted to build a garbage collection system and then use that, you probably could, but one is not supplied. Did I study computer science? Yes, at University of California, Berkeley. How much do I intend on supporting features to reduce memory errors? Well, it depends. Like, I would like to reduce memory errors, all other things being equal. But all other things are not equal. Like usually the methods that people propose for that kind of thing introduce friction on code globally, which I'm not willing to suffer given that memory errors are usually not that serious for me. It's just I'm not as freaked out and scared and running around like a chicken with my head cut off about memory errors the way that some people seem to be. Like it's some weird religion that's the worst kind of error ever and we should eradicate it. Well, we should eradicate it if it's easy to eradicate and doesn't cost us anything. But it does seem to cost us some things. So I'm going to deal with that the way I deal with everything in this language, which is to do the best I can to provide the best solutions that work for the kinds of problems that high-end ambitious games try to attack. And that certainly means not managed code or whatever. Can I uncomment the 8-bit stuff? Not yet, because we have to fix this other thing. Yeah, I'll release the source at some point. I just don't want to think about it yet. I'd like the language to be pretty usable with no huge surprises, with a basic, pretty good feature set, and with a decent amount of sample code before I release it. You know, otherwise people waste a lot of time wondering like, how does this work and how does that work? You know, maybe by the end of the year, like if I could release it on January 1st, 2015, just an initial thing, that would be pretty fun. Yeah, well, an alternative to managed code is something like what Rust does, where you know you have a borrow checker and all this crazy stuff. I don't like that. I mean, it's a cool direction to go, and I'm glad that Rust exists, and I'm glad those guys are working on it. But as far as I'm concerned, it's a research project that is going in a direction that I personally don't want to go. Anyway, what kind of keyboard am I using? This. Everyone asks that. This is my keyboard. Okay. Let's fix this. So in the C converter, which is the name for the file, so this is not that much code. It's 1,200 lines, and it's what outputs the C program. Well, and a lot of this is comments that I gave up doing things certain ways. I bet I forgot some Boolean operators. Maybe not. No, I guess not. Wait, was mod equal in there? And yeah, I don't have mod equal in here. I fixed the bug before I ever triggered it. I knew it. My spider senses were tingling. Okay. Oh, and I bet. No, because the unary operators all get handled by this. Okay, let me make sure that compiles. All right. I've never typed a mod equals in a program. How many toes do I have? That is not a relevant question. How many toes I have. All right. Okay, so implicit constructor is handled, for example, here, emit code for declaration. Okay. This is weird because this looks to me like a thing that should do it. If it's a struct, oh, okay, no, this doesn't actually initialize the things. This creates the function definition. Let me see if that happened. So, implicit, okay, this is good. This is good. So here, it did still generate the constructor function that fills out all these values. It simply didn't call it, which is maybe not so. So I'm just looking for places that do these things. I guess that's a. Yeah, okay, that's just all the same place. Here we're writing the function. Whoa, that's a bug? So here we're calling an implicit destructor and we're supposed to implicit destroy anybody else down like who's nested. So if you own memory on a struct and that struct owns memory on a struct, then when you destroy, they have to destroy. I'm calling the constructor instead of the destructor here. It's a paste error. Fix two errors without having to encounter them in code. On the one hand, that's good. On the other hand, God only knows how many errors like that I didn't catch. Wow. Okay. So actually, let me look at when I call new. Okay. When I call new on something, I generate the implicit constructor. Okay. And, you know, this is crazy because I'm outputting text code for a C program, right? So I'm outputting this function call and then putting the type name and like a type definition and all that. And I'm kind of going to be a bad person and paste this, and then I'm going to see if I can factor it together. Okay, so okay, so this is a little confusing. So here I'm in the code that outputs a declaration. So a statement, if you're going through a block of statements, those statements, one of them could be a declaration. And here is saying get the struct description and output stuff. But this is a different case. This is when you're defining the struct, that declaration, then we output all this stuff. But what we want to test for is when you're using a struct, right? Not when you're defining a struct. Oh, my T's going to oversteep. T emergency. So So here, this code here, we emit the code for the type, and then the name of the variable, and if it's a dynamic array, whatever, and if it's an array, we output the square brackets and all that, right? So down at the bottom here, if it's got an expression, right, we put the equals. So if it has okay, so cleanup, pasted from new or delete, please factor together once it works. So basically, all this stuff up here has defined the thing. So I'm going to printf a semicolon. I'm going to do indent because you want to indent each line. And then, whoops, actually, let's do all this. So we only want to do that stuff that I just said if use implicit constructor, right? Then, and this is on the stack, so we want to take the address of that, and then actually the variable name is what? Name. We just called it name. That's easy. So this here is the name of the type. So we make a function called implicit constructor and then the type name, right? So that's there. And then this is the name of the variable that we just declared. So we're taking the address of it and passing it to the implicit constructor. That ought to do something. I mistyped. Type isn't. Type isn't. No, it's inst, not isn't. Let's see if that does. Okay, well, we output the code incorrectly, but we output something. So let me go. Now, it says it's in the source file, but we're using these line directives, so I could add an option sometime to not output the line directives, but okay, so I just didn't put the semicolon in the new line, which I thought I did, right? So we really want that, and I just didn't put those. So why didn't they happen? Because I'm printfing them and not to the file. I hope somebody caught that. Yes, somebody caught it in the chat, I think. Thank you. Ha. Dumb mistake. Yep, there's the semicolon in the new line right there in the output. All right, so it still works at compile time, and let's do it at runtime, and it works. So that's good. Whoops, I meant to type a message, but whatever. We checked it in. Let me take out that bytecode run. Actually, no, we'll leave the bytecode run in because we're going to do some new things. Peanut gallery programming. Well, to be fair, I noticed the problem before I looked to chat, but yes. All right, I'm going to eat 2 more chocolates. Yeah, I need my screen to just flash. Why SVN? Because Git sucks for large assets, and I want to use one tool all the time. So on the witness, let me, for the sake of illustration, whoops, I mistyped. So here's my witness folder, and let's just right-click. Well, let's just right-click here. And let's see how much data is here. Actually, the best way to do this is with a command shell like this. So if I dir witness, wait, how do I recursively? I don't ever use dir. I don't use the command shell very often, honestly. I know Unix a lot better than DOS. How do I get all the file? You know, I'll just do this. So I think it's not doing this because it's not actually, you know, this thing that Windows does when you, there we go. That's what I wanted. It's goofy that this doesn't count for the same thing, but whatever. Okay, so the witness is 60 gigabytes, all right? So just try syncing 60 gigabytes all the time in frickin' Git. Yeah. And plus, so the advantage of Git that people like is it's decentralized and you can do like these pull request kind of stuff. But we're a centralized project, like we're building a single well-defined product, so that selling point of Git doesn't matter. The other big selling point, of course, is that you can do commits and stuff when you're offline, right? You're not as tethered to the internet, and that makes more sense to me, but I don't really miss it, you know. The Git ignore is probably someone else's, so a couple people on the team do use Git for their personal stuff, like they might use it for large local modifications that they're going to mess a bunch of stuff up and not check in for a while and then check in. I don't personally do that because I like to minimize the number of tool sets or tools that I try to use. It makes my life nicer, so I would rather just use one source control than do something goofy like that. But there's at least 2 people on the team, I think, that that may have used Git at one time or another, or may still use it. Yeah, most of that 60 gig is not source code, right? Most of that 60 gig is binary assets, but they have to be revisioned the same as code because you want to be able to say, what was the build from last Tuesday or whatever, right? Or what, like when people here in the office update, they need to get, like when you change code and data, the changes need to be in sync or things will break. So it needs to all be revision controlled together. Okay, so let's make arrays of things like floats and ints initialize. So I'm going to leave the my char and dude for later. I'm going to leave all this stuff. I'm going to say f array float let me see if this even works. Let's do C style and capitalize this because why not? Float num values. I array is an int of num values. Printf I array sub 37 equals array 37. I don't know, 78. F array percent %F. I don't have my printf checker loaded into this program, so I could get myself in trouble by messing up the printf. Okay. Okay, so those are definitely not initialized. Certainly they are not initialized in the bytecode. Look at this. We've got some really crazy numbers. And they're probably not initialized in C either. No, they're not. Although those are cleaner numbers than the bytecode came up with for some definition of clean. So we need to implement this on both sides. We'll start with the C because that's the one that we just did for the structs, and so it's code that we've been poking around in. Okay. How do I want to do this? Well, oh, right. Well, in that code that I just added, that implicit constructor calling code, we also need to do it for new. We need to do this. Okay, we got a 2x2 matrix. We need to support bytecode local, bytecode nude, C local, and C nude, right? Because you can declare an array on the stack, or you can new it, and we need to do each one. Sorry. Now the default value for anything is just going to be zeros. For any of these arrays. So we're just going to mem set it for the sake of being fast. We're not going to like output a loop that does this. Did I say nude? Nude. Okay. So this code that we just pasted, right? Oh, you know what? Should I factor that together? I should. I should be a good person and factor that together. All right. Let's clean this up first. Now that we know, because I never want to do this immediately because you may be wrong about what you need to do, but I think so. This code is all identical. I'll put a new line here just to show that. So blah, blah, blah. This part down here, outputting the string, is no. So I'm just gonna factor this part out. So bool use constructor equals should use implicit constructor inst. We're going to do the same thing. And we're going to say if use constructor there. Right? So there. Okay, that, it's not a factoring out of a huge amount of code, but this part is just different enough between here and there that if we try to share it, it's maybe going to make more of a mess. So let's define this thing. Where should I put it? The top of this file is a mess. Let's put it here. So we have bool should use implicit constructor as type instantiation inst. Return true or return false. Okay, that in theory, oh, I didn't change one of the, yeah, okay. I thought all that was localized, but we do it again. We have to emit a close paren after all this malloc stuff. Okay, so that worked. Well, it compiled, sorry. Okay, so, well, we didn't break the bytecode, but we shouldn't have because we didn't touch it. And this still works. Okay, so you know what? I'm actually, just to reduce the amount of noise and so we can focus on the new thing, I'm going to comment out all these things that work. So I'm going to say these work, incomplete, these do not yet work. But we're focused on this. Okay, so this does not work either in bytecode or compiled. Now instead of, like I said, I'm going to use memset, and instead of setting the funky values like we've been doing, I'm just going to set it to 0 because, you know, it's memset. We're just going to use 0, and if it comes out 0, we'll be happy because it has not been remotely coming out 0, so it's a good enough sign that it's working. Okay, so, oh look, I didn't delete that. All right, make sure it compiles. All right, so that's in the case where it's a type instantiation. If it's an array, then we should have if definition array element type, right? An array has an element type and then some values and stuff. You know, I just realized that if we have an array of structs, we need to do that as well. And that does need to be a loop. So that's an extra test case. You know what? I'm not going to do that tonight because I'm probably going to get tired. But array of structs local. Welcome to writing compilers. So, I mean, maybe we'll get to that, but maybe not. All right. So if it's an array element type, if it's a leaf type, you know what? We'll probably do the struct, actually. That's easy. All right. If, you know what I'm going to do before I do any of this? Before I proceed, I already said that later, so I'm going to do all this stuff. I'm already going to do all this stuff to do the initialization. And then later, I'm going to add a way to explicitly not initialize, right? Like you can assign something to uninitialized. While I'm writing all this code and I'm at the place where this code is, I might as well say add that flag. We're not going to set the flag yet, but I'm going to add it and put it around this code just so that I don't have to figure out where this code is later. So so if declaration flags, I'm going to call it declaration is explicitly uninitialized, right? Why might you want to do that? For performance reasons, for example, like you may not want to iterate over a giant array of structs and set them all to 0 or whatever, right? That's an interesting case. It's an optimization for when you have an explicit constructor, but it's all 0. You should memset it instead of calling the constructor anyway. We'll do that later. It's an easy thing to do post hoc. All right, so I got to add this flag. So We sure do have a lot of declaration flags. All right. We'll set that sometime later, but in the meantime, we're bracketing all this code by that. So if it's ever... Why did I do this? Precedence is not that way. It's like that. I do that sometimes, and it's bad news. Okay. So if we have an array element type, let's go look at that. Array element type. Where's the array length information? Oh, it's in the type inst. All right, let me look at some other code that outputs arrays. Where's the declaration for an array? Okay. This is actually the other piece of code that we're going to have to insert this in, right? Oh, I do it right up here, actually. Right, this is the thing that outputs the array declaration, right? So I never demoed this, but there's sort of a provision for actual multi-dimensional arrays. So you can have a dimension list. It's not just one dimension like in C. I haven't really tested that, but this sort of goes over and figures out how many elements there are. And you know what? I'm going to factor that out so that I can use it. Int num array elements equals -1, and forget int. This is a signed 64. Signed because I don't ever use unsigned anymore. I used to love unsigned, and it's too many problems. I don't use it. Oh, but I don't actually multiply this. I'm actually outputting number times number times number. That's crazy. Let's not do that. Let's just figure out the number and do this. %d. I hope I don't break this. Num array elements. You know what? I'm going to leave this commented out. Num array elements times equals n. Whoa, except that we have to start it at 1. I don't want to start it at 1 out here because if we're not an array, I want to make sure it's -1. So, all right, that in theory does the right thing, except this has to be LLD, like LL Cool J. So now I want to assert num array elements is greater than or equal to 0. Okay, auto. So we assert that we have an inferred type because we shouldn't have gotten here if we didn't do type inference. And int size is the size of that, and we want to assert size is greater than or equal to 0. A printf output file do indent fprintf memset the target 0 size times or percent LLD. I haven't finished that yet, but size times num array elements. We'll call this element size. Don't I already... Maybe I cache element size somewhere. Element size is not... No, it's just my own code. All right. And then the destination is just going to be name, right? Is it called name here? Yeah. Except that's %s with name. Let's see if that compiles. Okay, that compiled. So this one we're doing right now is just the stack version. Once that works, I'm going to factor it out, and then we'll call it from the new as well. And, you know, maybe I should... Wow, syntax error. All right, let's see what the output looked like. Oh, maybe we don't have mem set. Whoops, tests. Whoa, okay, we didn't, right. We forgot the semicolon. The reason we leave it off is because we, you know, for many other types, we might be putting an equals after it or whatever. So, you know, that's just how it is. In the big city, memset identifier not found. So in our boilerplate, memset is in string.h, I think. Okay. Hey, look, they're initialized to 0. That is good. We'll look at the code again. Hey, look, it's got an extra semicolon, but what do you want? Well, let's fix it. So like I said, we expect, because we're outputting for an expression often, so we don't terminate this statement. Okay. The sizes are correct, right? A float is 4 bytes, and there's 100 of them, and that's all good. So we've got progress. We have, whoops, C local is done. We need C nude. So how can I this is one of those annoying things where the printfs make it different enough that you kind of don't want to factor it because it's almost as much code after you've factored it. Let me think about this. Let me look at the code for new or delete. So if it's an array, see, this looks kind of different, right? Like if we're newing an array, we don't use any kind of bracket syntax. We just output stuff that says malloc and some size. And you know what? This is so straightforward because, oh God, no, we don't compute the size here, right? Why did I do that? I guess I did that in order to match the C convention. Right, if it's a struct, C's idea of the struct might be a different size than what we think it is. Maybe, although that should, honestly, that hopefully should never happen at this point. Hopefully all those I's are dotted and T's are crossed. Well, Now the tricky thing is, we're outputting C code, and we're outputting for an expression, and that expression may have side effects. So this is complicated, right? Instead of evaluating this expression twice, we do a thing where we put it inside the malloc, and we pass that malloc directly to the implicit constructor if there is one. What's the malloc that clears things? Isn't it, what's it called? Is it calloc? Is it, this is kind of a horrible hack, but, right, allocate and zero initialize array. Okay, so this is the super awesome greatness. So we're going to say malloc routine is malloc. If our declaration is not explicitly uninitialized, we have to get that somehow. Wait, how would you? This is interesting because there's no way to syntactically. It has to be on the new flag. It has to be on the new. So. Because this isn't a declaration, you're just saying new whatever. It's an expression, not a declaration. So we have to say, if not command, does new and delete have flags? New or delete? They don't have flags. Let's put flags. New is explicitly uninitialized. Did I spell that right? Is explicitly It's hard to read capital text. Int. New flags is 0. So if command new flags and new is explicitly uninitialized, then malloc routine equals calloc. Oh god. See, the implementations are kind of different. I mean, in principle, you get, and it's the same. Calloc just does a memset on malloc, except maybe there's an optimization because the operating system has to zero memory when it comes back. I don't know. In cases where a heap page is new, you wouldn't have to zero it. I doubt C runtimes do that. Okay, well, we haven't built a test case for this. So, we're going to new these. Actually, you know what? Let me go back here and take out this calloc so we can see. Well, there's 0. This is unfortunate because how do we know if it works? I know. We're going to make our malloc routine spoo alloc, and in our boilerplate, this is so stupid, but this is what we're going to do. In our boilerplate, we're going to define a type void star spoo alloc int size void pointer equals malloc size memset pointer ox I don't know, AF size. Return pointer. Whoops. So that's our very elite spoo-alloc function. And so syntax error string. Oh, right. I'm doing this not too often used C convention where you can just put a bunch of strings and they'll automatically get concatenated, but if you put a semicolon, you break that. All right. That didn't work. Why didn't it work? Let's take a look. In the C code. So there's our spoo-alloc. I hope I'm using memset properly. We're not calling spoo-alloc anywhere. Why are we not? F array. Okay, this offends me. Why are we not calling spoo-alloc? Wait. Whoa. Okay, this is really... Oh, because first of all, I didn't do this. First of all, there's multiple things I did wrong. So first we got to do this. We have to actually not hard code the string malloc in there. But now it's going to call spoo-alloc all the time, which I guess is what we want, honestly. I mean, well, no. We'll just do it for array. Yeah, we should just do it for arrays now. So all that other logic about array element type and stuff, from over here, for example, I didn't do. Okay, I'm going to delete this old comment. Oh, look, I typed in array elements equals 1 twice. Okay. So if we have a type definition, which I think we have an inst already. So if we're an array, whatever, you know, we could have done that from so this is all weird. So I imagine the bytecode implementation is going to be a lot cleaner and straightforward because you can just do the same thing both times. Because we're outputting to C, we have C's idiosyncrasies. Okay, so I think maybe that worked. It's just what does FA look like as a float number and stuff. Let's put %x, %08x for the integer. Why is that not? Oh, I'm in the C file. I'm in the C file. Put %08x in the right place. Okay, so that worked for at least the int. And I believe it worked for the float because if you poke a random value into a float, you'll get something weird. The question is, what's a good thing that I can poke with memset that'll produce? No, you know what? I'm just gonna take for granted that it works because you know what? Let's look at the code. Yeah, so we're calling spoo-alloc with that size. Spoo-alloc is mem setting, right? So now I'm going to go, and instead of spoo alloc, we're going to be boring and call calloc. So now they should both be 0. Oh, calloc isn't just 0? Wait, what? How does calloc work? Number, size. Oh, number of elements and each size bytes long. Oh, jeez. Those routines in C that work that way don't make any sense. So, okay, you know what? No, it is spoo alloc. But spoo alloc is different. It just mem sets to 0. All right. Where is my... That's how tired I am. I'm just flailing around the windows. Okay, so that's 0. It's not this messed up -0 like we had before. So I'm pretty convinced that's working. That's 2 down. 2 down. Is anyone following this, or does this make no sense? What I just did actually will work for array of structs nude as well. I think. It's just could use maybe some optimization sometime. So I believe that's actually done. I'll test it. Why not just call calloc and spoo alloc? I could do that. You know what? I'll do that because there might actually be a performance win there. Anyway, it's shorter. All right, cool. So that's working. As you can see, the bytecode is still hosed, but that's the only cases that we still have. I may have missed some operators compared to C, but I don't implement all C operators. And some of the operators, if you actually look, if it's a single character operator like times or plus or whatever, then I just use the ASCII code for that character as the operator, and at the head of that function, it says, oh, if it's an ASCII character operator, just output that. So a lot of single character operators would not be listed in that list. No cupcakes, no, because I wanted to be a little healthier, so I just did chocolates and salty pepper somersaults. Can you see that? Yeah. No, we're not doing bitwise operators in this language. They're going to be intrinsics. There's various reasons for that. For example, most CPUs will let you rotate a number, bitwise rotate, but there's no operator for that in C. And equal and or equal, you usually use that for flags. That's 99% of the time what you use it for. We're not going to use that for flags in this language. So really, the times that you need it is when you're doing non-flag bitwise operations. And in that case, like it's very important that you have bitwise operators, but I don't think they, or operations, but I don't think they need to have syntax reserved in the language. Okay. I want to go to bed around midnight, so let me start cranking here. Bytecode builder, new or delete. We're going to do the bytecode new case. All right. Oh, damn. There's a bug in what I did. There's a bug. So I have to go back and fix it. So to decide if I was an array, I check this array element type member, but that's also set for dynamic arrays, which are stored differently. So I just totally broke dynamic arrays. Like, they're going to crash the program or something. So I need to find my isDynamicArray function, and I'll make an isStaticArray or isNonDynamicArray. And I'll call that. Where is that? It's in parser.cpp. It must also be in general.h or something. IsDynamic well, that's very simple. Is non-dynamic array. So I need from C converter if is non-dynamic array. Does that take a type definition? I just was there. Yes. Here's our spoo-alloc. Okay. Crisis averted. Okay. I get another treat. Now, I'm not going to have 12 different array type classes. That's exactly how it's going to be. Bits and booleans are going to be sort of basically the same thing. Yeah, Mr. Fourth Dimension has exactly the right idea. That's how it's going to be. That was one of the things I thought about doing today, but I did this instead. All right. So okay, so if it's a non-dynamic array, then we have to find that explicitly uninitialized. So where I'm editing, in case people are lost. Oh wait, this is the wrong place anyway. Oh no, it's not. This is well, things work slightly differently in the bytecode system. I need to think about this for a second. Basically, anywhere where a dynamic array inits, we need to init a static array too. So it happens here, which is in a declaration. It happens here, which is as an implicit constructor as a struct member. I'm not sure where the new dynamic array is. Maybe that's not implemented. Like if you knew an array, I might not have ever made one, like a nude dynamic array. Or maybe that's actually handled here. It may be. I don't know. Let me clean up this old comment that is ugly. Let me see. I want to do the newer delete version. Okay. So if we're newing something and it's got an array element type, oh, new of dynamic array not yet supported will be easy. I just have a lot on my plate right now. So that's an amusing internal compiler error you can get. I've just scribbled that on this piece of paper, so I'll do it sometime soon. Let me put that in the file. I'm just going to paste this line because I'll know what it means. I'm probably not going to get to it tonight, but that'll just remind me to do it. Have a lot on my plate right now. Okay, so here, this is bytecode to compute the size. Like, you can't just statically compute this, right? So we're emitting instructions to like multiply the element size times the count, where the count's already in a register from evaluating some other expression, right? So like this emits